That brings us to the end of mechanics 3. So we've learned about momentum, kinetic energy, potential energy, and so forth, right? But let's return back to our preview question, right? Our preview question, I asked you, does aaron score, right? And Arshan correctly identified the type of collision. It's a completely inelastic collision, so they're stuck together, right? So they're stuck together. So aaron must cross the goal line. So he has to go in which direction? Right or left?
To the right.
Exactly. We have to go to the right to score. And Timothy is trying to prevent that, right? So we figure this out through momentum, okay? So our equation for momentum is m1v1 plus m2v2. What's so special about a completely inelastic collision? What happens to the masses, Arshan?
They stuck together.
They're stuck together. So m1 plus m2, right? And they have a single final velocity because it's just one object, right? So we will know if aaron scores by the direction of our final velocity, by its sign, right? Because I mentioned that the signs of velocity are what trip most people up on momentum questions, okay? So aaron is moving to the right, so is that positive or negative, Arshan?
That's positive.
It's positive, so everything going to the right is positive, so Timothy has a negative velocity. So substituting in the numbers, we get 80 kilograms for aaron, and he's running 10 meters per second, 100 kilograms for Timothy, and he's running 5 meters per second, but is he running positive or negative?
He run negative.
Run negative, exactly. So adding together our masses, we get this, right? So if we get a positive final velocity, aaron scores and he wins the game, okay? So we get 800 plus negative 500 all over 180 equals, well, 800 minus 500 is positive, right? Positive divided by a positive number is a positive final velocity. So yes, aaron does score. Okay, aaron scores. Okay, so what about the kinetic energy? Arshan, what's my equation for kinetic energy?
Is 1/2 mv squared.
1/2 mv squared, correct. Okay, so who has more kinetic energy, aaron or Timothy? Well, again, let's just substitute in the numbers. So for aaron, 1/2 80 times velocity squared. Kinetic energy for Timothy, 1/2 100 times velocity squared. Okay, so solving this out, we get 4,000 joules, and we get 1250 joules. Okay, so obviously aaron has more kinetic energy, right? So aaron has more kinetic energy. However, we can actually find this out without even plugging in numbers, because again, the MCAT is a time-based test, right? So we know that kinetic energy is proportional to mass. How is kinetic energy proportional to velocity?
It's squared.
Squared, exactly. Squarely proportional. Well, comparing the kinetic energy, the masses of aaron and Timothy, they're about the same, right? They're like, there's not very much difference, right? However, aaron has double the speed of Timothy, okay? So double the speed means what? Quadruple the kinetic energy, okay? So we would expect aaron to have quadruple the kinetic energy as Timothy, and that's exactly what our results show us.